All right, I want to take a few moments to talk about this assumption that xi's are non-random in a simple linear regression model. Also, when we have more than one xi for multiple linear regression, we also make this assumption that xi's are non-random. Okay, so let's start with what does that mean? That means that the xi's are, that the x values are assigned, and then we are using those assigned values, and then there's some error occurring, and then we're getting out a y value, right? So x values are assigned, they are fixed, right? These are fixed numbers. Here's the randomness. The randomness comes in our error term, okay? And that randomness makes y random, okay? We are assuming there's no randomness in the value of x, right? So if I were to find the expected value of that x value, it will just be itself, because the expected value of a number or of a non-random number is just itself. The variance for that non-random number will just be 0. There's no variability in it, okay? It's a fixed number. So is this a realistic assumption? That's a good thing to ask yourself. In a lot of cases, it is an assumption that we make because it has nice statistical properties. When we make this assumption, we can use this linear regression model, and there's some nice things that result from that assumption. But that doesn't necessarily make it a good assumption, okay? An example of where it would be appropriate is if we are assigning the values of x and then measuring y. So where might that happen? In an experimental type study, right? In an experimental type study, we would assign x and then measure y. Suppose we are using like a certain amount of a chemical on a plant, and then measuring the height of that plant, right? So say x is like the amount of a chemical put on a plant. And then y might be like the height of that plant. Maybe this chemical is supposed to help that plant grow taller, right? In this scenario, we are assigning these values, the amount, and then we are measuring this. This is measured. And in that measurement, we would assume that there is some variability, right? That's what makes y a random number, because there's going to be variability in that measurement, right? Every time that I put on the exact same amount of chemical, I'm not always going to get the exact same height of that plant. And that's what makes y random. And that's what makes xi fixed, because I decided how much to put in. All right, put onto that plant. Now, in reality, this is often not an appropriate assumption, okay? For example, a very simple linear regression might be, xi is your, let's see, what would be height and weight, for example, where you would maybe say someone's height should predict their weight. Height and weight, right? Both of these are measured, right? And so there's going to be slight amounts of measurement error in each of these. We're not assigning a height, right? We don't tell people what height they are. They're just naturally that height. And so in this case, this assumption is really not valid. So then the question is, well, how much does breaking this assumption, how much does it really matter? Okay, and that's where we get into some fun discussions about measurement error, and then there are additional other models that might be more appropriate that will, allow xi to be random. Okay, and also sometimes the randomness in xi can kind of be pushed into this randomness here, and then you say, okay, well, that basically, this randomness here is going to absorb this randomness in xi, and I'm not really going to have too much of a, I don't really need to worry too much about that this assumption was broken. Okay, but it's important to understand, what does this assumption mean? And this is what it means, all right? It means that if we're running an experiment where we fix x, right? And then only y is what's random. That's what that assumption is saying.